Next, we're going to talk about the mean value theorem. Now, the mean value theorem is of immense importance in interpreting the derivative. It allows us to interpret the derivative on an entire interval. And it provides a very nice visual that I would like you all to see in the graph that we're about to do. So let's look at the statement of the mean value theorem. If f is continuous on a to b closed, differentiable on a to b open. It doesn't matter what happens on the boundaries. You can have a corner, cusp. All that matters is it's curvy between a and b. Then there exists some c in a to b with this symbol right here is like an E-ish type thing, and it's read in math in, and it just means it's inside the interval. So here there's some c in a to b, some c in the interval a to b, some c value down there, with blank. Why is that blank? Well, we're going to figure out what blank is. Again, by using a stick. The only stick I have conveniently located here is a flagpole stick, so just roll up the flag, and then we will see what we want to see. Well, right here we have a function. We have an interval a to b marked off, and I marked off the points on the function. I'm going to mark off one more thing. A line connecting them. A line connecting them. And what we're going to do is look at the derivative inside the interval a to b. And we're going to look at the derivative by considering slopes of tangent lines. Do you see anything that happens as this tangent line travels between a and b? Does anything jump out? Well, something jumps out at me, but I also know what we're looking for. So let's let this tangent line travel on this piece. Does anything significant happen? Well, it would go like that. Does anything significant happen? Maybe I'll try this side. What if we start here, let it travel on the curve? Does anything significant happen that we can interpret? Does anything significant happen? Well, it may not be obvious, but something highly significant happens. Right here. Maybe it's more here. Something significant happens. On this interval, a to b, we have a tangent line which is parallel to the line between a and b. And we can interpret both of them using derivatives. Or, well, not using derivatives. We can interpret both of them algebraically. Right here, the slope of this tangent line is the same as the slope of that line. We know all about slopes of lines. What is the slope of that line? I'm going to put it here. And I'm going to put the slope of the line on the right side of the equal sign, and then the other thing involving c on the left. What is the slope of that line? Well, it's the change in y over the change in x. What is the slope of the parallel line? Well, we're saying there exists some c where at that c the tangent line is parallel. What is the slope of this tangent line? So the derivative evaluated at c. Mean value theorem is very important. It allows us to understand the derivative on intervals. And we will do that when we're graphing. And I always like to see the mean value theorem by letting these tangent lines travel across this curve. I'm just going to remark, there's a special case of mean value theorem what happens if, so here, f of a and f of b, well, the points a f of a and b f of b are on a diagonal. What would happen if they were at the same height, the same y value? The special case of mean value theorem, sometimes abbreviated MVT, where f of a equals f of b is called another theorem called Rolle's theorem, named after a guy named Rolle. I'm not aware of anything else he did in math except get his name attached to this. The special case of mean value theorem where f of a equals b is called Rolle's theorem. And what would that look like if f of a equals f of b? Well, what would that look like? Let's draw a function. Let's move the y-axis over. What would that look like if f of a equals f of b? Well, it would look something like this. A would be here. B would be here. If f of a equals f of b, they're on the same horizontal line. What would the right side of this equation be? 0 over b minus a, which is 0. And it would say that there exists some c in AB such that f prime of c equals the slope of that line equals 0. So I'd say f prime of c equals 0 here, if we call that c. I'm not too concerned about Rolle's theorem. I'd much rather you see tangent lines traveling through curves using a mean value theorem interpretation. It's very important. In a Calculus 1 class, we see some consequences of it which are important, but we don't ever really use it directly too much. But I do want you to have a visual interpretation of it by interpreting tangent lines. It's very important. And I think the tangent and parallel lines, I should say. Well, no, the tangent line being parallel and then interpreting the one using derivatives and the other using the slope, change in y or change in x. I think that's very important. I think it's very useful to know, and it's very useful to see.